Yes, this is your boy Saidi Nasa. Yeah, welcome to my channel. Today we are going to discuss about this question, which goes like using the life expectancy, that is the whole data set from Kaggle. Kaggle is a website, simulate and model the relationship between life expectancy and socioeconomic factors in different countries. So here we are given a link, so you'll have to hold the shift. Here you'll have to hold control, then you click on that link, so that it takes you to that URL, that location where the data set is. So here we are required first to input the life expectancy data set into SPSS and clean the data for any inconsistencies and all missing values. So what you'll do, you open SPSS. I have here a blank page in it, a blank data set. Then you go to file, then you go to import, then you look for the format in which that data was saved. And our data that we got from that site was in CSV data. Then you tap on CSV data, then it will show you the location of where your data is. Sometimes it might not go there, but you have to look for it. But mine, as for my case, I had already tried it out. That's why it has taken me to the exact location where my data is. So you select the life expectancy and then you open. When you open, you wait for it to process, and so that it can be able to import the data. So after it processing the data into the SPSS, then you press OK. When you press OK, you wait for it to bring out the data. So as you see, all the data from the spreadsheet has been imported to the SPSS. So as for this, let's try to get this on board. Yeah. So this is the data set that we have. In order for you to view the data into its formats, and to be able to change the name, the type, the width, the decimal, the label, the values, the missing, the columns, alignment, the measure role, you can do everything here to modify your data. So I think we have finished number one on how to import the data. Let me hope you have all got how the steps of importing the data as after you have downloaded it. So this is my data, as you can see here, that I had already modified. So in the variable view, you can see I had modified everything, added labels, then added the values. I labeled the values with numbers, so that I can have a quick processing, because when the values are in numbers, there is a quick processing than when it is in strings or numerics. So that's Roman numeral 1. Then we go to Roman numeral 2, which says use the SPSS to perform a multiple linear regression analysis to model the relationship between life expectancy and socio-economic factors such as GDP, adult mortality, and immunization rates. So what we do, we come here to SPSS, you go where you had where you had put your data, then you go to analyze, you go to regression, you go to linear. So when you go to linear, the reason as to why we are using linear, it's because we are having a lot of independent variables that are significant to the dependent, or that are affecting the dependent variable. So the dependent variable, according to the equation, what we have is the life expectancy. So among the life expectancy, there are those that under the independent variables, there are those that were requested to put. First of all, we had the adult mortality. Then we have the GDP, and then the immunization rates. For the immunization rates, you have to put the diseases that are that can be immunized amongst all these diseases. So we have diphtheria, we have polio, we have measles, and hepatitis B. Yeah, after selecting all those, then you come to statistics. You have yourself selecting the R squared change in order for us to get to know the effect, how well does the independent variables affect the dependent one. Then descriptive, like to be able to, for the simulation to describe for us about how they have affected. Then the partial, then the case wise. Then after you press continue, you come to plots. For the plots that we need, first of all, we shall get the Z spread. We place them to the x-axis, and the Z residue we place it to y-axis. Then after all that, we request the simulation to give us the data on the histogram and the normal probability plot. Then you press continue. So when you press OK, this is what the outcome will be. The outcome will be this, as you can see: regression, correlation, that's all the coefficients, case wise. So we shall, as you have seen, that's the outcome. That's for the Roman numeral 2 question. Then for the Roman numeral 3, they're asking us to simulate the effect of changes in socioeconomic factors, and they are giving us, e.g., increase in GDP, decrease, all that, on life expectancy, and discuss the potential impact on the policies. So what we do here, we have to we do the same steps that we did the previous question, of going to the analyze, going to the linear, the regression, going to the linear. But as for this case, we shall be using the socio-economic variables. So still the dependent is the same, but the social, they will be changing, whereby we have alcohol, we have the percentage expenditure, we have the total expenditure, we have diphtheria, we have population. All those are socio-economic independent variables. So we have the income composition, we have the schooling. So after selecting all those, we go to statistics. But for this case, you do all the same: descriptive, partial, case wise. Press continue. It's like the same same as the previous one. As the previous one, the result to this residue to this, histogram, probability, all that. As you see, the outcome will be of this kind. As you can see, this is the outcome. So we interpret, so this is it. And that is for the case of the third question. So we come to the fourth question, which asks us to validate our model by comparing the predicted values in this previous two, that is the Roman numeral 2 and Roman numeral 3 question, those simulations that we made, with actual life expectancy values, and perform a sensitive analysis to understand how changes in socioeconomic factors affect life expectancy. So what I did here, you come to to this, then you import the coefficients of each of the table. So the first one is the table of the socioeconomic variables, and you can see the significances are just 0.00, so they are significant. So we have that like 4 here that are significant, they're just significant. And when we come to this other one, the one that is having the immunization rates, for it, it's also the under significant. For them are having this less than value, which indicates that the variable independent variables are highly significant to the dependent variable, meaning that they affect so much the independent variable than the ones in the table 1. So that's what I gave as my conclusion here. So that's the answer to this question. Yeah, as you can see. So I think you have understood my my explanation to this. Then after, you can maybe provide a report for and summarizing your model, the simulation outcomes and the policy implications. So you do a report summarizing all those that you did. Yes, thank you. We'll meet next time.